about RDT, right?
Yes.
Now we'll look at Spark SQL,
Okay.
and also with this we'll look at in the Spark SQL we have two things. One is data frame and one is dataset. We'll look at it, both of it. Okay, and when writing the Spark library, either you can use data frame or dataset, or if you are writing code on RDT, we'll see there are three ways to write. These two are almost similar, it's just concepts different that when to use which. And RDT and data frame and dataset, all these three things you can write the code, but internally it is the RDT where you have to where it is the basic or the core of the Spark. So whether you write on data frame or dataset, it will be under the hood RDT will work. And
Okay.
what is RDT? As I told you, resilient distributed data set, right? And it is a core of the RDT, a Spark, core of the Spark. So this RDT, now one question which generally come, which can be asked is like, what is difference between RDT versus Spark data frame versus Spark dataset? This is one question which generally people ask.
Okay.
So RDT, when you will be using RDT, so with this they mean that what is difference and when to use which, right? Like you can use either RDT or Spark data frame or dataset to write the your queries and your program. Then how you will decide that shall I use the RDT or the Spark data frame or the dataset? So in the actually, okay, let's just look at first what is Spark SQL and dataset. Then will we come to the comparison of them. So data frame is also distributed. Okay, like how your RDD is distributed. Let's suppose if I have multiple servers, your RDD distributed. If I have 1 GB file, okay. Have I told you about partition? I think no.
Yeah. 128.
Okay, yeah, okay. 128 is the default partition. Okay.
Yes. Mm.
Now tell me one thing. Now let me just let's suppose that you have this file of uh, 1 GB. Okay. Then uh, it will be divided into partitions, right? And
Yes.
each partition is of size 128 MB. Okay. Now why 128 MB? Because your default size of your block is 128 MB. So with this, how many partitions it will create? It will create 4 partitions. Okay, so if you have, let's suppose 2 GB of or let's suppose 300 GB of data, how many partition it will create? It will create 300 GB into 1024 MB by 128. These many partitions it will create,
Mm.
and those many partitions will run parallelly. So how it will create? Like I think 128 to 1, this will be coming as 4. So it will create 1200 partitions. Okay, from the 300 GB of data, it will create 1200 partitions. So it will 1200 partitions will run parallelly all at a time. Okay, if your cluster has that many resources, it will run 1200 partitions, or it will run in batches. Like maybe it will run depending on the resources. Maybe it will just start with 100 parallel partitions running. Once 100 will complete, then next 100 will come. Similarly, it will run 12 times. Okay, and your each partition we call as a task. one task. You got it?
Yes.
Okay, when it comes to task, okay, so this is something which I wanted to tell you regarding stages, and all we'll see it on the Spark UI. But for now, you just understand one partition is one task. So if it has created 1200 partition, it means it has created 1200 tasks, and each task will run on multiple servers, or on one servers you can run 2 3 tasks. Now, uh, where the task will run?
Server.
Which server?
It's server.
On the worker node, right?
Yeah.
It will run on worker node, and on worker node you will have executors,
Yes.
correct? You have executors where your these jobs will run. Now, how many executors it will create, that you are going to tell Spark that I need these many executors. Okay.
Executors means tasks, right?
No, not task.
Okay.
On the worker node, let's suppose that this is your worker node. Okay. Let's suppose these two are your worker node, and this is your driver. These two are connected, right?
Yes.
This is driver and these are worker node. So what driver will do?
Distribute, I
It,
mean, sub
it
tasks be
yeah,
divided.
it will, whatever the code you submit, it will convert into the DAG. Okay, and DAG and all we'll see, but you just think that it will convert it into the task, and then it will distribute to the worker node that you run it. Then on the worker node, we have executors. You can have multiple executors. These are the executors. And in these executors, you will be running it. Now, your question is why we are using these executors, why not working on the using the full worker node? If that question is coming to your mind, so let's suppose this worker node, okay, there is no eraser. Let us go to this slide. Let's just move to, let's suppose this one. Okay, this is these slides will come later, execution mode and all. Let's just first finish that. So let's just this is driver, this is worker. Okay, and this worker is of, each worker has the capacity of, let's suppose 32 GB RAM and 100 GB space, disk space, and 16 core. Core is CPU. Okay, and okay, one more thing. One partition need one core. Okay, one partition need one core to run the task. Okay, so now let's suppose this is the 32 GB RAM, 16 GB, 16 core, and this you understand, right? Core and all.
Yes.
Yeah, and 100 GB. This is the capacity of this worker node. All three worker node has this capacity. Now you have one job where you have a.txt as the table. Okay, and it is, let's suppose 2 GB. Okay, then maybe you don't need these many space, right? 32 GB, 16 core. What you will do with this? If I'm using full resource, full worker node, okay, just to process the 2 GB of data, means I'm wasting the resources, right? I'm not fully utilizing it. So maybe once I run the Spark job. Okay, there is some Spark submit command. We'll see about this. But once you write the Spark sum, or when you are submitting the job to the driver, you will write there that number of executors. I want two. I want two number of executors to run my this job, and each executors will be of like core. You will give that I need two core on each executor. and I need a memory of 4 GB. Okay, so
Okay.
let's suppose you submitted with this configuration. Then what it will do, it will start two executors for you, one and two. Maybe here and maybe here one executors are depending on your resources. Okay, so that it will do. And now you will run your this job on these two executors. So let's see, after that you submitted job b.txt where you have 10 GB of data, right? You still have spaces here, right? Because you have only used two core of two executors, means you have used four core, and you have used 8 GB of RAM from 32 GB and 16 core. So still there you can have multiple other executors running here, right? You are getting this or not?
Yes, yes.
Yeah, so with this way, you can have multiple executors running on the worker node. So that's why whenever you submit any job, it will your jobs or your jobs will run inside these executors.
Okay.
Getting it?
Yes. 16 core is something like GB only, right?
No, 16 core, like you have core means CPU. You need core to run the process. Like any of the memory, or if you do any calculations and all, okay, it needs CPU. Like if you check your laptop will also have some core. Maybe two core or four core depending on your laptop, or eight core, whatever what you are using. Intel i5, i7, what you are using.
I7. Yes.
Check in the i7 what how many core is there. I
Okay.
think it has four core, I guess. Okay, core is helpful when you are running multiple. If you have four core, means you can run multiple four process. You can run multiple parallelly. Four
Okay.
tasks you can run parallelly. If you have
Mm.
16 core, then you will. Let's suppose that. Okay, let's just come here. You have how many executors you have? You have two executors. Means how many core you have used here in your executors? If you submit this job, let's suppose you
Okay.
submitted this job, how many core you are using?
2 core.
Two core per executor.
4.
Four, right? It means you can run, let's suppose, and how many from 2 GB, how many partitions you will create for one?
1 GB 4
Yeah, for
partitions.
1 GB 4, so 2 GB 8. From one, see, if you have 1 GB of data, you will
Yes.
create four, like 128, 128, 128, 120. That will be 1024 MB. 128 into 4 is 1024 MB. So 2 GB has 2048 MB. So double of it. Means in 1 GB you are creating 4 partition, in 2 GB you will be creating 8 partition.
Ye-
Getting it? So how many tasks you will create?
Task will be 8.
Right? 8. 1, 2, 3, 4, 5, 6, 7, 8. But you have only 4 core, right? This means that first these 4 tasks will run parallelly, and after that, this once this is completed, this will run.
Yep.
Got this?
Yeah.
But let's suppose that you defined here that I need on each executors I need 4 core. Let's suppose you mention like this. In that case, you will in just in one shot all your task will run because you already have 4 core.
Yes.
Okay. Also, like how your whether your this will be fast or slow, that also depends on memory. Okay. After maybe I will take one session that how to decide after once we complete this. Okay, during optimizations and all, I will tell you that how you will decide how many core I need, how many executors I need, what will be the memory depending on your data size. So in RDD, okay, you will have you don't have tables. Okay, you will, let's suppose you have a.txt as file, you will read it and then you will implement you read in, let's suppose you read it on one RDD. Okay, after that on this RDD you will implement other transformations, like let's suppose filter and all. You have to write something like this, like filter, then I on this you will do some RDD2 equal to RDD1 dot group by something like this. Okay, you cannot write SQL on RDD, but on the data frame you can write the SQL.
Okay.
Okay, it is though we are just using the data frame, but sometime you may need to use the RDD. Okay, but let's just first try to look at this, then we'll see when to use RDD, when to use the data frame. So Spark SQL introduced tabular data abstraction called data frame. So when you are reading anything, any text file, let's suppose I here if I am reading a.txt on RDD, I have to do the operations like this. If I am reading a.txt into the data frame, I can directly write the query on top of it, normal SQL query. Like let's suppose I was doing filter and group by, right? So I will write, let's suppose filter I was doing on age column. Here I was doing the age column where age is greater than 30. And then I'm grouping it by, let's suppose I'm grouping it by candidate ID. Or let's suppose just the, or no, I cannot group it by employee ID. Let's suppose group it by age. Okay. So here you will write select, let's suppose I'm getting sum of age from, let's suppose when I inserted a.txt, I have given the table name as A, from A where age is greater than 30 and group by age. So this is your SQL query. And similarly, you can write it on the RDD like this. Filter where age is greater than group by age and then dot sum. So same thing you can write in RDD in the RDD as well as in the data frame. But you have to write in the Scala way or Python way like this, that applying the filter here, group by here. And also there are some optimization difference between RDD and data frame. We'll see that. But basically you can understand that if you are writing on the data frame, you have structure on your table, structure on your data in the tabular format. Structure on data, with that I mean that your data will be in the tabular format. Let's suppose that I have a.txt and it has column like employee ID, then you have age, let's suppose only two column. Okay, then how you will do, while reading the a.txt, you have to split it. You have to split it based on the comma, and then you will just read the age out of it, and then you will do it. But if you have this file, you will directly read into the data frame, and you can directly write the query on this. Means when you work on the RDD, you have flat file, but when you work on data frame, you have tabular format.
So basically, flat files should use RDD.
Yeah, when you have flat file, or there are other way also, like when you have unstructured data. Okay, let's suppose that I have data something like this in the logs, right? You see the logs file does not have a structure,
Yes.
right? If my file is in the CSV format, and I have the JSON format, or I have the XML format, it has some structure, some semi structure. If your data for size data is semi structure or structured, you know about structured data, semi structured data.
No, but
Okay, then
general idea I have.
just write that topic, read about it, what is structure and semi-structure.
Okay.
But same structure data means data will have a structure. Like if I tell you about JSON, sorry, CSV, right? CSV will have something like this, right?
Structure.
Employee ID, all will be the comma separated value, right?
Yes.
If you open any Excel file also, you will see that it is comma separated, or maybe if not comma separated, then let's suppose it is separated by hash. Okay, these we call as the structure data. Semi structure is JSON, XML. This we call as the semi structure, because in the JSON we can have the nested JSON, and sometime maybe you don't have the, let's suppose I have a name, okay, and then age like this. Sometime you may not have the age in some of the JSON, right? So JSON, XML, these we call as the semi structured data, and CSV is the structured data. You write this topic and read about it, structure versus
Okay.
semi structured data. Okay? Structured, semi-structured, and unstructured. Unstructured data is log. See, semi-structured data, when I say JSON, it has some structure, right? Like name and age will be there. In CSV, you will always have CSV call as a structure because it is separated by either by the comma or by hash or by space, anything. And JSON will also have some structure. XML will have some structure. That's why we call it the semi-structure. But logs does not have any structure. Means if you want to read anything from log, you don't know, right? Sometimes your let's suppose you are printing the log, something is coming at the first place. Okay, maybe in the next line it will coming at the third place. So you have to write some regex regular expression to extract things from log. So for the structure and semi-structured data, we will be using data frame. For the unstructured data, you will be using the RDD. We'll see all those differences, but that is one difference. Data frame is data structure or domain-specific language working with the structure and semi-structured data. Data frame store in more efficient manner than native RDD, talking advantage of their schema. Okay, so when you store into the data frame, it will like more efficient because it is taking the advantage of their schema because your a.txt, CSV or JSON will have some schema. So it will take the advantage and will store it more efficiently. It use immutable in-memory, resilient, distributed, and parallel capability of RDD and apply structure called schema to allow data Spark manage this. See, this I told you, right? Under the hood, it will be RDD only. So it is telling that it will take the parallel capabilities of RDD and apply a structure called schema. Means I am under the hood working on the RDD only, but I am just applying a structure schema on top of it. Like I have the so I'm applying a structure schema so that I can query on top of it because you need schema, right? If in your DB and all you will have a schema there on, and then you can query the database, right? So here also, if you want to do any query, you need a schema on that, on top of that file or that. Unlike an RDD, data is organized into name column like table in relational database. Okay, so in RDD, your things are not organized into the columns, but in data frame, it will be. Do you know about compiled time and runtime? You are using Java or any language? Okay, you know that about the compilation.
One is job, some
Uh,
exit. Like compilation is committing.
Not committing compilations. When you run any Java job or anything, it will first compile to check whether it has any issue or not,
Yes,
right?
yeah, yeah, yes,
And the
exactly.
Maven, have you used this Maven project?
Yeah, I just used
Okay.
in some years back.
Okay, so you know that, right? In the Maven, we use this clean compile command, right?
Yes,
Where it will compile and check if your code has any issue or not, if anything is missing,
yeah,
have you missed any colon or anything, right? Let's suppose you are writing any Java code and you miss any colon, then this compile will give you the issue.
errors. Yeah.
Okay, and let's suppose that if you are not compiling, then what will happen? Now, let's suppose that if you don't have this compile, right? Then if you don't have then this compile, then what will happen? It
We
will,
may,
yeah, go ahead.
errors may be
Yeah,
not
so
available. Yeah.
we miss the error, right? During this compile time, then what will happen? If I run it, it will fail, right?
Yes,
Right. So it's good that I am capturing things on the compile time only. Let's suppose I am running it. So there are two way you can get the capture the issue either during the runtime or during the compile time. Data set actually find the issue in the during the compile time. Okay.
okay.
Why? The reason is it is strongly typed language. And one more thing, with that strongly typed language, what I mean is like during compile time, it will check whether you means in the compile time also. Let's suppose that what I'm doing, I have defined one integer. Okay, I have defined integer equal to let's suppose I define one this one a as integer. Okay, and let's just give it as null. Okay, at the beginning I give it null, and then after that what I'm doing, I'm assigning a equal to let's just give a name, or let's just give it a month, January. Okay. I have what I have done here. I have defined a as int, but I'm assigning a string to it, right? So this is a issue. You will get the compile time error during this. That you are telling that a is integer, but you are assigning integer to a string, right?
Yes.
So this is the issue. So these things actually Java capture at the compile time only.
Okay.
If let's suppose I'm not if this compilation is not available in some language, then it will be captured during the code running time, right? During when
Mm.
your code will you will run your code, that time you will face this issue. So this data set provide you compile time type safety. During the compile time, it will check all the types and everything, right? So the difference only between the data frame and data set is compile time type safety of the RDD API. Means when they say RDD API, because under the hood it is RDD only, right? Whether you are using data frame or data set, under the hood it is RDD. When your RDD has some schema plus RDD, it means it's data frame.
Okay.
Okay, schema plus RDD, it means data frame. Schema plus RDD plus type safety,
Type safety is something.
which during the compile time only it will check what you have assigned the types are correct or not.
Okay. Okay.
Okay, you what you have given means it will check all the types what you have used in your code. That
Okay.
is the compile time safety. See, actually, in the how we are writing uh, data frame. Okay, and one more thing, this data set is only available in the it is not available in Python or R. It is only available in Java and Scala.
Okay.
Why? Because R and Python does not support this compile. It does not have compilation. It will check during the runtime if any issues has come or not.
Okay.
Okay.
So only the difference between dataset and data frame is compilation run.
Right. It will check all your types during your compilation.
Okay.
So, but there are use case that when you will be using what? Okay, that will be seeing, because see, if I have, why this data frame has come? Can you tell me?
For structured data.
Right, for structured data there are some optimizations also, but if
Mm.
you see here you can see that writing the code with the RDD is difficult, and also the storage also we see that previously, right? If Spark know the schema, it can efficiently store the data. So why typing is matter? Okay, why this type safety is matter? Because if you have type safety, there are typos and logical error caught during development only, right? Let's suppose that you
Yes.
use these things and you deploy it, then that time you will see the issue. Then that is a bigger issue. Then it's good that you get the things during the compile time only.
Yes. Yeah.
See, Java and Spark will know this data set is only data set API is not available in Python, because it is checking these things on runtime. There is no compilation in the Spark.
Okay.
So we call data frame in the data frame Spark and all it will also doesn't see when you write. Let's suppose that you have a.txt, okay, and it has two. I showed you, right? It has two column, employee ID and age. Let's suppose in the PySpark or the writing your Python, you wrote that select. Let's suppose you wrote select salary, select salary from a table, but your a table does not has any salary column, right? Only has employee and the it only has employee ID and age. Okay, so this issue data set will capture during compile time only, but data frame and all it will see during the runtime.
And, okay.
I think this is
RDD is something. Data frame means it uses schema RDD,
right.
unstructured data. Unstructured.
Yeah. Come again. Come again.
RDD means unstructured data
No,
processing.
RDD can be structured data also. You can, and the RDD, you can read any type of data, be it a structure or unstructured. You can read JSON also. You can
Okay.
read CSV also. In the RDD, you can read both structure as well as unstructured data. But in the data frame dataset, only structure and semi-structure, not the unstructured,
Okay.
like log file.
So this is the only difference between all these three.
Uh, no, there are some optimizations also available in dataset and data frame. We'll see that.
Okay. Okay.
There are some optimizations also available in dataset and data frame, which is not available in RDD.
Okay.
But from the user perspective, or when you start you writing the code and all, this is one difference, that RDD has a schema, RDD plus schema, you have a data frame, so you can directly write the queries on top of this. Yeah, let me know if you have any other thing.
I just want to know one summarized summarization of RDD.
Okay, let's just look at we'll go to the RDD versus data frame versus data set, then there we'll cover that again. Okay.
Okay. Okay.
Starting in 2.0 data frame API merged with dataset. Okay, now data frame and dataset is merged with data frame and dataset is only one, it is merged. Now dataset take two distinct API characteristic, strongly typed and untyped. A strongly typed, like previously we have like data frame and dataset. Now we have only one dataset API, and it take two API characteristics. One is strongly typed and one is untyped. With this, what it means previously, whenever we have untyped, that means data frame. When we have strongly typed, we were data set, right? Before actually in the Spark, what was happening? I showed you here, right? We have two things. One is data set, one is data frame.
Yes.
So similarly, now what Spark has done, it has come merged the data frame and data set, and it gave you only one API, which is data set, and it gave you two distinct characteristic. Like you can either use the strongly type or untyped. Means
Okay.
when you using means in the Python, these strongly typed things won't be supported. You can only use the untyped type API. Means compile time safety and all, will you will only get it into the Scala and Java. So it is only just it has combined a data set and data frame into one, and it give you two things, like either you use the strongly type or untyped. Means here also it differentiate within the data set, within the API. Means you merge the data frame and data set, you made the data set API, but under the data set API, you have two things, strongly type and untyped.
Okay.
See, data set by contrast is called the strongly typed JVM objects. Okay. And data frame as generic untyped JVM object. Both are JVM object, but here it is strongly typed. Means it is at the type also, that what type of data, like integer, string, and column check, all those things it will strongly, in the strongly type it will check all those things during the compile time, and untype it will check during the runtime. And the data set API is only available in Java and Scala. Okay, now you ask that what you ask?
RDD.
See, in RDD, okay, when Spark launched, right, in with 1.6, it was only supporting RDD. Okay, Spark 1.6, I remember it was only supporting RDD. In the RDD, you can read any file, if either it is CSV, JSON, okay, and then XML. Okay, but let's suppose on after that you have to parse the data in the JSON. Okay, let's suppose you have CSV, right? And in the CSV, how the CSV data will be? It will have let's just give again two column, EMP ID and age. Okay, let's suppose I have 130, 2, 15, something like this. Okay, so how it will be stored into the Excel? Have you seen the Excel file into the text notepad?
Yes.
It will be something like this: EMP ID, then you have age, then
H.
you have 1 comma 30, then you will have 2 comma 15. Have you seen this?
Yes.
Right? So let's suppose if you have to read it in the Python file or Java file, you will, and let's suppose this file is a.csv. Okay, then if it is a.csv, I have to first read it, then I have to split it based on the comma, and then I have to, if I want to get the employee ID, then I have to take the first the value, and else I have to take the age. If I'm taking the age, I have to split it, and then I have to take the second value, right? Here, I'm splitting it based on the comma, because I have what let's suppose I have a.csv, then I will split it. I will split is a function which you can use it. So I am splitting it based on the comma. Once I split it, let's suppose I have this as a. In the a, I will get, if I am getting the get zero, let's suppose I am using get zero. In this case, I will get the one, two, something like that. These values I will get. And if I'm doing a dot get one, I will get 30 and 50. Okay. But if you are reading the same file a.csv into the data frame, you will get something like this table. You can directly write select. If I want employee ID, I will write select employee ID. Your issue cleared, or you still have something,
No, no, I got it. Yeah, thank you. Yeah.
right? This is the difference when you are writing the code, but there are other difference also. We'll see that. Okay, from the optimization perspective.
Okay.
Other than the transformations, other than the optimizations, uh, basically, I would say the difference is like whenever you have any structure or anything, just read it and use it the data frame or data set. Okay. Or when you have unstructured data, use the RDD. I told you, right? Spark data frame and data set has some optimizations also, right?
Yes.
There that is coming from the catalyst optimizer. Okay. This is present in the Spark SQL, which actually give it some optimize it internally. If you write any query, it will do the optimization on top of it. But this is not what optimization it will do, how it will do, that we'll see. But these optimization is not done on the RDD. Okay, if you run any code on the RDD, this catalyst optimizer won't come into the picture to optimize the code. Or I would say, if you are writing any code on the sequels, right, that would be optimized using the catalyst optimizer. But if you are using anything or writing any code in RDD, you yourself has to optimize everything. But under the hood, if you are using Spark SQL, catalyst optimizer will optimize your code.
Okay.
This optimizer make query run much faster than the RDD counterpart. If you are writing same thing in RDD and same thing in Spark SQL, then Catalyst optimizer will optimize your code, okay, and it will run more faster. We'll see how it is optimizing. So Catalyst in modular library, which built on the rule-based system, okay, like constant folding, rule-based in how you have null check and all those things. Let's just I have one slides. We'll just go to that. Okay, because of the Catalyst optimizer, your Spark SQL, where you have data frame and data set, will run faster than RDD. Got it?
Yeah, yeah, got it.
Okay, now I'm moving to how this Catalyst optimizer is working and how it is making faster. If you have any question, you can ask. Then we'll move there. See, many questions will come to you on this Spark Catalyst. What is difference between data frame, data set, RDD? Okay, when to use which, the difference between RDD and these things, I would let me just tell you again. So in the RDD, difference between RDD and the data frame or data set, what is that? RDD plus schema is data set, right?
Yes.
Data set, because now I'm telling you data set because data frame and data set is merged to one
Right.
API, which is data set. Okay. In the now RDD plus schema equal to data set, correct? Under
Yes.
the data set, you have data untyped API and type check API, right? Wherever you are checking all the integers value and whatever you have used. If you are checking the columns, type, what you have, the things you have used during the compile time, then we call is the data set. But if you are checking on the runtime, then we call it a data frame. And
Yes.
Python is not supporting the data set. It is only means type check. It is only supporting the untype check. And also there are other thing also in the data set and data frame, that is catalyst optimizer, which optimizes the query. So if you are writing the same code in the RDD and the or and means not same code with mean with that I mean you will write in the SQL into the data frame, and on the like Scala way, let's suppose you write the same thing like filter and group by in the RDD, and then select query with filter and group by into the data frame, then your query which you are writing in the data frame may run faster than the RDD because of this catalyst optimizer. And how catalyst optimizer will optimize the things, we'll see it. If you see here, right, you can connect to the Spark through the JDBC, or you can write over the console. You saw that, right, when you open this Spark cell, right? It will open you console and you can write the code. So you can with the user program you can connect to this data frame API. Okay, and through the user program you can connect to the Spark also. If you see this diagram, you can see it under the Spark SQL. You will have catalyst optimizer, and then you are using the RDD only, right? If you are using data frame, then also you are working on the RDD, and if you are directly working on the RDD, then also you are working on the RDD. But when you are working on the data frame, you have this catalyst optimizer in between, which is optimizing your query. So this is, I told you, right, when I was teaching you that Spark driver was making a plan, right? When you submit any code or anything to the driver, it will first create a plan out of it,
Yes.
right? So how it is creating plan, this is the way how in this way are following these things, it is actually creating a plan.
Okay.
Okay. So let's just look at it. And in this plan only, it is optimizing your job, not in the RDD. Okay. These things I'm talking about the specific to the data frame or data set. Means I would say, yeah, data set. Okay. These things won't be coming into the RDD. In RDD also, it will create the plan. Okay. That we'll see. But this plan will be optimized. Okay, you see in the data frame also it will be creating the plans, but so not data frame. In RDD also, actually a Spark job is to create the plan. It will create the DAG. Okay, it will create plan in RDD when you writing the RDD code also, or you are writing the data set code also. But what I'm seeing here, this is the data set plan optimization plan. How it is optimizing the data set. I told you, right, RDD will be slower than data set. So why? Because it is optimized by the catalyst optimizer. So that we are seeing here. How data Spark actually optimize the data set code. Okay.
Okay.
Okay, I will tell you the difference between RDD plan and the data set plan. In the RDD, in the data set plan, we are not in the RDD plan, we are not using any catalyst optimizer to optimize that plan. But under the hood, driver will create plan for both RDD as well as data set. Now, let's suppose once you submitted your SQL query, okay, it will create the unresolved logical plan with unresolved. Let's suppose let's just create one query, right? Same query, I will be using it. Select. Now, this EMP ID and age has two column, and you are using this EMP ID. You are selecting EMP ID and with the filter where age is greater than 15. Now, once you let's suppose you submitted this code to the Spark. Okay, you submitted this code here to the driver. Then what driver will do? Driver will do the unresolved logical plan. It this what it will do, it will just check your these things. EMP ID, okay, I have it will create one plan like I have age greater than 30 and I have to get the EMP ID, something like this. It will create one plan. Okay, why we are calling it unresolved logical plan? Because you it has not yet checked whether employee ID and age is present in the employee table or not.
Okay.
Okay. Here it will just create plan like this, that EMP ID I have to get, and where filter is like age is greater than 30. We are calling it unresolved because it has not yet resolved the column which you have given in your query. Okay, resolving means it has, maybe you can write query, right? Let's select salary. Select salary from EMP. Okay. Then for this also it will create one unresolved logical plan, like I have to get the salary. Okay, it will create something like that. For this also, for wrong query also, it will create the unresolved logical plan. But when it moves to the next phase where you have catalog, what catalog has is actually in the catalog, it will see everything. Catalog will have all the info. It can connect to the your metadata. It will see. It will. Let's suppose you gave the a.csv, right, from employee table. You want to check. It will go to the database and check whether employee table has the employee ID and age or not. Whether it has the salary. So when after this phase, it will fail. This query will fail. It will give you the error that salary column is not present. But with this, it will go to the catalog. It will see that, okay, employee ID and age is present. So let's just move to the next step. Got it?
Yes. Yeah.
So now from the unresolved logical plan, it will create the logical plan. So logical plan means now it will check, okay, this is, it will means plan will be same. Okay, but here we are calling it unresolved because it has not checked whether the employee ID and age is present or not. But after checking using the catalog, it will check, okay, this employee ID and age is present. So now we call this plan as the logical plan. Now optimize logical plan. Okay, now we are seeing that how it is optimizing the logical plan. And then it will create the physical plan out of this optimized logical plan. And based on the cost model, we are from the multiple, it will select multiple physical plan. From on the basis of cost model, we will pick one of the best physical plan from it. Select best physical plan out of it. Let's just see how you are now. Okay, from here to here, we call is the catalyst optimizer will work. Okay,
Okay.
this part will catalyst optimizer will work. Now let's just see how it is optimizing the logical plans. We understood till here.
Yes.
How it is optimizing the logical, that is the main functionality of catalyst, that it will optimize the logic. It will from the logical plan, it will create the optimized logical plan. Let's just see how it is doing that. Logical plan internal representation. So how Spark see the query or the user intent. Okay, this is like it will create the plan out of it. Different series of transformation are applied on logical plan to get the structure plan and make it optimize physical plans. So transformations here mean filter, group by. Here also, here also you are using the filter, right? If you are filtering things. So this is a filter, and filter is a transformation. Have I showed you filter and all? That is the transformations and action. I think I have covered, right? What is the difference between transformation and action?
Yeah. Transformation XML.
Okay, no action. Okay. Can you remind me tomorrow about the
Sure.
transformation and
Sure.
action? Okay. But anyway, once we from tomorrow we will have this session, so there we'll see the transformation and action, not an issue. But just remind me if I miss it.
Okay. Sure.
So this is the filter. So filter we call as a transformation. So that's what it is mentioned, that it is the series of transformation. Let's suppose that you are using here filter, right? On that of filter, let's suppose you are doing something else, like a window function you are applying and a row number and all. So if any filter you will apply, so that's why we are calling it. You may apply multiple filters. So all the filters and whatever the transformations you apply on it, like map and all, so those will be, we are calling the series of transformation is will be applied on that logical plan. So whatever you wrote, so let's suppose you have written some multiple complex query where we have multiple of transformation, like transformation one, then transformation two, then transformation three. So this is the series of transformation. So during the logical plan, it will create this series of transformation and then it will optimize it. Let's just look at how it is optimizing. What are the way to optimize it? See, these are the filter push down, column pruning. Okay, let's just look at what is a filter push down and what is a column pruning. Let me just give you one example first. Okay, let's just go to this example. See, this is one example, right? You have joined, okay. Then you are joining one data set. Let's just look at this query first. Understood this? Can you tell me what it is doing?
Query. So
Yeah,
it is selecting customer ID from tables
right.
with key column.
So you have three table here: customer, store, and data div, right? Data dimension or data div. And on which column you are joining? Uh,
Cu-
this customer,
Customer SK.
right? Customer SK, you are joining this. And also other table you are joining on sold date. Okay. And then you have filter greater than 1,000.
Mm.
So you have one filter here. You have join. You have actually basically you have two things. One is join and one is filter,
Yes.
right? Now let's see that. You have two join. You are scanning the data dimension. Then you are filtering things. Oh, just means scanning means anyway you will be reading all the data, all the tables, right? Scanning means reading the table. You
Yes.
have to scan the table if you want to do any means. You have to read the table, right? If you want to do anything. So you are scanning the table. You have filter and then you have join. Now let's just come to this. So let's suppose that your one join has 500 million record. This has 2.5 billion record. Then your other has point 0.1 million, point 1 million record. And so what you did, once you join this, let's suppose you join these two tables. Let's just take the examples from it. Okay, we have customer, stores, dimension. Let's just give it to the customer and I will give the store and dimension is D. Okay, S, C, and D. Let's just three table. C for customer, S for sales, you have sales data, right? Yeah, store sales and D for dimension. So let's suppose your customer has a customer data has 500 million record and your sales data has 2.5 billion record. You have to join this. Once you join it, okay, you filter it and from this let's suppose once you join you get 3 billion record. Okay, 2.5 plus 500 million, it will be 3 billion. And you have one filter condition also, right? Filter greater than 1,000. Greater than 1,000 you have one filter condition. Once you apply the filter, you got the 10 million record out of it.
Okay.
Oh, sorry, I think I got in the wrong way. Sorry. It will start from here. Sorry, I come wrong way. You are first scanning the store cells, right?
Okay.
First, you have to read the data, right? Means you will scan the data. So here it is S, here it is C, and here it is D. You scan the data. You have like 3 billion records. Okay.
Okay.
Means store sales, you have 3 billion record. In the customer, you have 12 million records, and you have one filter condition greater than 1,000, right? So from that you got 10 million record. From the to have 12 million records, when you apply the filter will reduce your column. This is clear or not? Do you understand why how I'm getting 10 million records or not?
Once again, please.
Okay. So if let's suppose I have this one table where
Okay.
I have employee ID and where I have employee ID and age. Okay. And here one, two, three, four. So here age is 30, age is 15, age is 16, and age is 12. Okay. So if I read this table, EMP,
Okay.
how many record I will get?
4.
4. And let's suppose on this I apply the filter. Filter where age is greater than 15. How many record I will get?
1.
1 or 2?
So 2.
30 and 16, right?
Yep.
Greater than 15. So similarly, I had 12 record. When I apply filter greater than 1000, I got 10 million record.
Okay.
Okay. And once I join this 3 billion record and 10 million record, I got 2.5 billion record.
Okay.
Okay. And now after that, what I did, I joined this record, whatever I got here, I joined this with 0.1 million record and I got 500 million record. Okay.
Okay.
So now this is one way to do it. Can you tell me what other way you can do? Let's just look at it and see the other way.
Okay.
Yeah, just look at it and tell me if you can, if you're understanding this.
First joining.
You have to read from below.
Yeah. First it scans both the tables
Just
and
look at the
come.
difference between these two. Let's just come here first. What we are doing here, we are joining all three tables that you know, right?
Yes.
From here you see that we are joining all the three table and we have one filter condition here. This is three table we are joining and we have one filter condition here. Correct?
Yes.
Now let's just comment here. So here what we are doing, we are scanning, we are filtering. After filtering, we are joining these two, and whatever the result we got, we are joining with this third table, right?
Okay. Scanning, then filtering, then joining.
Right?
Hmm.
Ultimately, we are joining all the three table. First,
Yes.
here we are joining these two, and then we are joining these two.
Okay.
Correct? Here we have 3 billion record. Here we have 10 million. We joined 3 billion and 10 million record. Okay. And then whatever the record we got, we join these two, 0.1 million and 2.5 billion record, right?
Yes.
Okay. Now look at this. Can you tell me what is the difference between there and here?
First scanning, then joining. Okay. Zero point 0.1 million.
But see the difference in the joining. What we are doing here, first we are joining store sale and the customers, right?
Yes.
And what we are doing here,
Store cell and scanning date field.
right?
Full collection.
Data dimensions after joining sales and customer, I was joining it with data dimension, right?
Mm-mm.
But here I'm first joining with data dimension, then I'm joining with scan customer customers table, right?
Yes. Yes.
Can you see the difference and tell me? Okay, one more thing. Let's just okay. Let me tell you these things. Okay, see, I have 3 billion record and 10 million record. I joined, right?
Okay.
Okay. So with this, can you see that if I let's suppose if I'm joining 1,000 record and 5,000 record, and in what one place I am joining 1,000 record and 100 record, which will be slower and which will be faster, which will take more resource and which will take less resource. This is A. Let's suppose this is A job and this is B job, which will take more resource, which will take less resource. In both of them, I am joining these two.
100 and 1,000. 5,000 and 1,000. Right. Okay.
Yeah.
100 and 1,000 should be less.
Should be less, right?
Yes.
It will get means more record means more resource you need and more time you need, right?
Yes.
So similarly, if you see here, I was joining 3 billion record and 10 million record, right?
Mm. Yes.
Ultimately, I have to join all the three table. So Spark thought in a way like why not join this first, right? I have only 0.1 million record. Why
Okay.
I'm joining with 10 million record? If I have to join, ultimately I have to join all the three table. Let's just join these two first because I have less record here, right? Only 0.1 million. If I join 0.1 million record and 3 billion record, I need less time, right? To,
Yes.
to process. So that's why Spark thought that, okay, let not do in this way. Okay, I wrote query in this way. Okay, I wrote query in this way, like you do in this way, but it will it process it and think that okay, if I do join 3 billion record and 1 million record, it will be faster. So let's just do in this way.
Okay.
After that, once I get the record, then join these two. If you see here, I got the record 2.5 billion and then I'm joining with 0.1 billion, right? So here, but here I am joining 500 million and 10 million. Here I was joining 3 billion and 10 million. But here I am joining 500 million, 10 million. So with this, what I'm saying to trying to tell you that Spark automatically think in the way that where the your data shuffling will be less and you are taking less time.
Okay.
You write query in this way, like let's just join these two table first, then join with this. But Spark internally calculate things and it will make you this optimized plan that instead of joining customer and sales store first, okay, instead of joining these two, let's just join these two because it has less record and this will be faster. You got
Okay.
it?
Yes. Got it.
So this is some kind of optimization which Spark do internally. And this is only available on dataset and data frame.
Okay.
If you write this query into the RDD will similarly do in this way. It won't optimize the code.
Okay.
But if you write the same thing on the Spark data frame, it will optimize your code. This is one optimization, but there are other optimizations also which it do internally. This is one example I'm telling you.
Okay.
Okay.
Yeah.
Now let's just see what are the optimizations it do. See, filter push down means moving the filter close to the data source. Okay, like doing the fill. Let's suppose that you have two things, right? You have A, B. Okay, you have to join A and B, and then filter the data.
Okay.
So if you give query like this, so Spark what will do? Spark will do. Let's just do the filter first, then we will join, right? Because after filter you will get less data. Correct?
Yes.
So if you write query something like this, Spark will move it to like let's just do the filter first, then you do the join and all. So there are something like push down predicate. Actually, these are available in the databases also. These optimizations and all, and they
Okay.
are column pruning. Means let's suppose that in your select query, okay, you have used multiple columns like A, B, C, D, all the columns you have taken. Okay, but you need and the final result you need only A and B. So it's unnecessary to take C and D, right? So it will do all the column, unnecessary column, whatever you need in the final result, those columns only it will do. Because let's suppose if I'm reading this data, I'm unnecessarily wasting the time. So those optimization it will do on top of this. So constant folding means let's suppose that you have age, okay, and you are doing that. Let's just add 1 plus 2 in all the ages, all the age. So in the constant folding, what it will do, it will see that, okay, this is constant, I can do it something like that. It will make it 3 and it will do something like age plus 3.
Okay.
Okay, so these are some of the technique like constant folding, column pruning, push down predicate, which it will internally use, okay, to do the optimization. This is one rule based optimization. Now other is cost based optimization, right? So these are this is actually the cost based optimization. Okay, these are the rule based, like selecting only the necessary column, moving filter close to the data source, pruning unnecessary column, constant folding. These are rule based optimizer. And there are other optimizer which we call as the cost based optimizer. In the cost based optimizer, only these things will happen. Like joining how it will do in the cost based optimization. Actually in the cost based optimization it will scan all the rows and all, and it will check how many records are there. Okay, and on that basis it will try to do the joins and all on the respective data. Let's suppose in this what Spark will do, Spark will scan the store sales customers and scan data. And then it will see that, okay, it has 3 billion record, it has 10 million, it has 3 billion record, it has 10 million record, and it has 0.1 million record. So after doing the cost based optimization, it will think that it will come up with a plan that instead of joining these two, let's just join these two first. Okay.
Okay.
So on the basis of cost based plan, it is coming on those things.
Okay.
And how there are some formula, actually you don't need to understand this much. You just understand that there is some cost based and rule based. And on the high level, that on the base cost base, it will look at all the scan all the tables, it will try to look at what is the maximum value, minimum value. Okay. And cost formula is something this, I don't think you need to know this much, but this is some formula which internally it used to calculate that how it will calculate whether I should use this filter. First, I should join these two and then do the filter and all. There is some formula which it will be using.
Okay.
Okay. So it will check at the column level statistics. It will check the man, max, mean, null count, average length, everything it will check for all
Okay.
the tables or whatever you are using. And on top of that, it will optimize. It will use the optimization, cost-based optimizer and rule-based optimizer, and then it will give you the final plan out of it.
Okay.
But these things are not available in the data RDD.
Okay.
Okay, so that's why we are using data frame in our query production and everything. You can use the RDD when you have some unstructured data.
Okay.
Okay, because you cannot create table on the top of the unstructured data. So mostly in case of RDD or in case of unstructured data only, we are using the RDD.
Got it.
Okay, I think this is something with the data frame. Few things are left. I think DAG and lineage I am seeing I have not explained to you. So action and transformation that we'll see during that. Okay, I will look at it. What I have not covered, maybe I will take cover that in the beginning, or from tomorrow we'll start the Spark Scala, or maybe day after tomorrow we'll start the Scala.
Okay.
I think there are few topic left. First I will cover that. Okay, then only I will move to others.